Hello class, so today we're on 3.7, finding roots using the quadratic formula. So let's first talk about what roots are. Roots, you'll hear me call them zeros or x-intercepts. Those are all interchangeable. Basically tell me when the function equals 0. So when the y value equals 0. Or you can think sometimes, when we'll talk about y, sometimes where it crosses the x-axis. So polynomials have as many roots, x-intercepts, or zeros, all the same thing, as its degree, or the highest power. We call degree whatever the highest power is in a polynomial. So for instance, this function here in blue, the highest power is 2, so we'd call this a second degree polynomial. If the highest power were 3, we'd call it a third degree polynomial, and so on. So knowing what we know about this, because the degree is equal to how many roots it has, this function should have 2 roots. However, not all zeros may be real, meaning that they don't cross the x-axis and are therefore imaginary or complex numbers. So take this function that I pointed out earlier, f of x equals x squared minus 3x plus 3, and I've graphed it here for us, and notice that it doesn't cross the x-axis at all. But knowing what I know about here, which is actually also called the fundamental theorem of algebra, it's that important, that this should have 2 roots. But since it doesn't cross the x-axis at all, it has 2 imaginary roots. So because it doesn't cross the x-axis, there are no real roots to this polynomial. That means both roots must be imaginary or complex. So let's go on talking about how to find zeros. There are a few ways to find zeros of a polynomial, and the most surefire way is through the quadratic formula. So when dealing with quadratics are second degree polynomials, such as this up here, or anything to the second power, we use the quadratic formula to find zeros. So this is how it works. If f of x equals ax squared plus bx plus c, where a, b, and c are just numbers, then x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I know it looks like a lot, but it's not as bad as it looks, I promise. So let's go find some of these roots of these polynomials. So let's take a look at this example here on top. We have x squared plus 6x plus 5. And we want to know, when does the function equal 0? So you don't always have to rewrite it, but I'll just rewrite it for us. When does the function equal 0? So, I will write the quadratic formula for us up here so we have it as reference. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So notice that the 4 and the 2 are in the formula. Okay, so first what I like to do is I like to define my variables. So I like to define what my a value is, what my b value is, and what my c value is. So a is the coefficient of the x squared term, meaning in this case it's going to be 1. B is the coefficient of the x term, so in this case it's 6. And c is the constant. It's the term without a variable, so in this case it's 5. And now what I'm going to do, I'm going to plug it all into this quadratic formula and simplify it and see what my zeros are. So x equals negative b, so negative 6, plus or minus the square root of b squared, so it's going to be 6 squared, minus 4, remember the 4 is in the formula, 4 times a, which is 1, times c, which is 5, all divided by 2a. Remember this 2 is in the formula as well, so 2 times a, which is 1. So I know this kind of looks like a mess, but we're going to go ahead and simplify this. And we're going to simplify it just as we read a book. So we're going to start from the top left, go to the right, and then simplify the bottom left to right. So we're going to have to revise this a few times. We're going to make a few simplifications. So just don't rush your mathematics. Okay, so my first simplification, let's see, -6, there's nothing to simplify out there, plus or minus the square root. Now I like to do these two separately, so 6 squared is 36, and then I like to do all this at one time. So -4 times 1 is -1, sorry, -4 times 1 is -4, -4 times 5 is -20, so -20, all over 2 times 1, which is just 2. Next, we can simplify under the square root, so we will. X equals -6 plus or minus the square root of 36 minus 20 is 16 divided by 2. Now, here's the thing. If the number under the square root is not a perfect square, then we would stop right here and say these are the roots. But because 16 is a perfect square, we will continue. And in fact, on all of these that we'll be doing today, they will all be perfect squares. So we will be continuing on all of these today. So let's rewrite it. X equals -6 plus or minus, and the square root of 16 is 4, divided by 2. So you might be asking yourself, Mr. Lucero, you said that polynomials have as many zeros as the degree of the polynomial, right? So this is a second degree polynomial, so I should expect 2 zeros. Why is there one equation? Well, that's where this plus or minus comes in. At this point, we're actually going to split this up into 2 different equations, where one is going to read -6 plus 4 divided by 2, and the other one's going to be -6 minus 4 divided by 2. So let's go ahead and write that. X equals -6 plus 4 divided by 2, and the other one is x equals -6 minus 4 divided by 2. So to simplify these, we'll continue simplifying, by the way. To simplify these, we'll simplify the top and then divide by the bottom. So -6 plus 3 is -2. Yeah, -6 plus 4 is -2. -2 divided by -2 is -1. Then down here, -6 minus 4 is -10. -10 divided by 2 is -5. So our two answers here is x equals -5 and -1, which means that this function has 2 real roots. Meaning, if I were to graph it, I'm just going to do a really rough graph here. This is -5 and -1. This polynomial would look something like this. It would cross the x-axis at -5 and -1. So both roots are real. Let's continue on to the next one. And in this case, this polynomial doesn't have real roots at all. It'll have 2 complex roots. So we would expect this function, knowing that, we would expect this function not to cross the x-axis. And if you were to graph it, it doesn't cross the x-axis. So again, I'll write our formula up on top so we have it for reference. And again, I like to start off by defining my a, b, and c. So again, a is the coefficient of the x squared term. In this case, it's 1. C is the coefficient of the x term. In this case, it's 4. And then c is the constant. It's going to be 5. And then I'll go ahead and plug it right into the formula. So x equals -b, so -4. plus or minus the square root of 4 squared, that's because it's b squared and b is 4, so 4 squared minus 4 times a, which is 1, times c, which is 5, all divided by 2a, or 2 times 1. And we'll go ahead and simplify this. Remember, just like we read a book, top left to right, and then the next line from left to right. So x equals -4, nothing to do out there, plus or minus the square root of 4 squared is 16. Then remember I like to do this all at once. -4 times 1 is -4. -4 times 5 is -20. All over 2 times 1, which is 2. We'll continue simplifying under the square root. So x equals -4 plus or minus square root of 16 minus 20 is -4 over 2. And this is where the imaginary numbers come in. Remember from yesterday, imaginary numbers are produced, I suppose, when we have a negative under the square root. And in this case, we have a negative under the square root. So let's recall how we take the square roots of negatives. So if we have the square root of -4, what we'd like to do is think about, okay, what is the square root of the positive? And that's plus or minus 2. But because it's negative, it's going to be plus or minus 2i. Okay? So the square root of -4 is plus or minus 2i. So let's go ahead and revise this. X equals -4, and then this plus or minus already takes care of this plus or minus, so in fact that's why it's there. Plus or minus 2i divided by 2. Now this is where we'll split it up into 2 equations. One's going to be plus, the other one's going to be minus. So we have -4 plus 2i over 2, and we have -4 minus 2i over 2. And unlike the last example where we could combine the 2 numbers on top because they're both real, we can't combine the 2 numbers on top here because one's real and one's imaginary. But what we can do is we can simplify this a little further because both of the numbers on top, -4 and 2, are divisible by the number on the bottom. So let's go ahead and divide that out. So -4 divided by 2 is -2. Then positive 2i divided by 2 is just positive I. And then to do the bottom, -4 divided by 2 is -2. And then -2i divided by 2 is -1i. So our two values here, our x values, is -2 plus I and -2 minus I. And we can actually write it like this. -2 plus or minus I. Because one's plus, one's negative. Okay? Or sorry, one's positive, one's negative. So this, like I said, if we were to graph it, it wouldn't cross the x-axis at all. Because both roots are imaginary. So if I were to graph it, and again I'll just do a very crude graph, it would look something like that. Actually, I think it'd be on the other side of the y-axis, but yeah, it would be. Anyway, so that's that. Let's go over a couple more examples here. Okay, so again, I like to start off by defining my A, B, and C. A in this case is 2, B in this case is -4, and C is -6. So let's plug it into the quadratic formula. X equals -b, so it's -4. Be careful there, because b already is negative, so there are 2 negatives there. Plus or minus the square root of b squared, so negative 4 squared, minus 4, remember that this 4 is from the formula, times a, 2, times c, which is negative 6, all divided by 2a, 2 times 2. So let's go ahead and simplify this. Negative times negative 4 is positive 4, plus or minus the square root of negative 4 squared is positive 16. Remember, a negative times a negative will become positive. And then negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. Remember, the negative times a negative will become positive. Then all divided by 2 times 2, which is 4. Now we can continue simplifying under the radical some more. X equals 4 plus or minus the square root of 16 plus 48 is 64, divided by 4. And since 64 is a perfect square, we'll continue. X equals 4 plus or minus the square root of 64 is 8, divided by 4. And then at this point, we'll split it into two equations. So one's going to be x equals 4 plus 8 over 4. And the other one's going to be x equals 4 minus 8 over 4. And since both the numbers on top are real numbers, we can combine them. So 4 plus 8 is 12. 12 divided by 4 is 3. And then the second x, 4 minus 8 is negative 4, divided by 4 is negative 1. So our two x values here would be negative 1 and 3, meaning that this one does have x-intercepts. It crosses the x-axis, so it would look something like this. Negative 1, and this would be 3. It would be something like that. All right, let's do one more example together. And again, I'll rewrite the quadratic formula. If you write it as many times as I do, you'll have it memorized. Which, it's never a bad idea to memorize this thing, really, if you have the time. Okay. So again, I'm going to start off by defining my variables, a, b, and c. A is 5, b is 8, and c is 5. And now I'll plug it into the formula. X equals negative b, so negative 8, plus or minus the square root of 8 squared minus 4 times a, which is 5, times c, which is 5, all divided by 2a, 2 times 5. And then now it's time to simplify. So x equals negative 8 plus or minus the square root of 8 squared is 64. Negative 4 times 5 is negative 20. Negative 20 times 5 is negative 100, so minus 100, all over 2 times 5 is 10. We'll continue simplifying under the square root. So x equals negative 8 plus or minus the square root of negative 36 over 10. And we can take the square root of negative 36, and that's going to be 6i, because the square root of 36 is plus or minus 6. Because there's that negative, it's going to be a 6i. So x equals negative 8 plus or minus 6i divided by 10. And here's the thing with this. Notice that neither 8 or 6 is divisible by 10, and we can't combine 8 or 6 because they're not like numbers. Therefore, we can leave our answer just as it is. So, x is equal to negative 8 plus or minus 6i divided by 10. This is the most simplified version we can get of that answer. Kind of. I mean, we can split hairs if we want, but that's good enough. So that's all I have for y'all. Get started on the worksheet and let me know if you have any questions.